to me through Take Lessons, and we can communicate that way. So just let me know. Glad to hear you guys can hear me. That's awesome. I'm going to share my screen now. Just let me know if you can see what I'm sharing. Hopefully you can. If not, please let me know. Okay, thank you, Zara. All right, so let's dig right in since we're a little bit behind. So intermediate science, obviously today is science. I'm going to go over basically the main goal of today is about charts, reading charts, learning how to read charts. That's the goal. If you don't know too much about the section, it's 35 minutes, 40 questions, 53 seconds per question. In layman's terms and basic terms, that means you don't have very much time. There's 7 passages, 4 to 7 questions per passage. In layman's terms, that means don't read the passage first. I mean, for some people, that's the right thing to do. But for most people, do read the questions first. Read a question and try to solve it. You don't have much time. Give yourself that focus. Section is made up of graphs, charts, summaries, blah, blah, blah. It's made up of charts and reading, basically, like charts and graphs and reading. There is some science knowledge required for this. Not very many questions rely on it, about 4 questions. Biology, chemistry, physics, and earth and space sciences. I'm going to provide a little link for you guys so you can brush up on the science if you want to. So I'm just going to, okay. Is everybody following along okay, Zara or Clarissa? Is everything I'm saying making sense so far? Madison, also. Anybody? Okay, good. So one of the things that they're going to test you on is experimental design. That means, like, do you know what an independent variable is? Do you know what a dependent variable is? Do you know what the difference between an observational study and an experimental study is? That stuff, it's not going to help you necessarily like get a perfect score, but it's kind of one of those things that it just makes your life easier on this test. So observational studies means you're just gathering data, like counting the number of leaves on a tree. Experimental studies, which is more about what this test is about, is that the scientists are going to change variables depending on what they want to study. So in the example I give here is they're saying, like, how much water do you give the tree? Well, deciding to give the tree no water and deciding to give the tree all the water it needs, that is, I guess you could say, manipulating the variables to see what the outlook is. So experimental study means you manipulate things. Observational studies, it means you just observe. Independent variables are the variables that that the scientists change. So in the example I gave, it's how much water. That would be how much, that would be the independent variable. So if you maybe in your study you like gave some trees no water, some trees 1 liter, and some trees 2 liters of water, that would be the independent variable. And the dependent variable would be the count of the number of leaves on the trees, meaning, like, that's what I'm looking to study. But that's not what I'm looking to manipulate. I'm just looking to see, okay, well, how many leaves on the trees are there? So the independent, the thing they're manipulating is almost always 99% of the time is the X variable, and the dependent is the Y. Everybody good so far? Zara, Clarissa, you guys good? Any questions? Do you guys have anything particular that you want me to go over? Anything that you want to know about or have questions about or anything like that, you can always put it in the chat. Like, I'm happy to go off script and kind of, give you guys my 2 cents. But if not, I'll just go through my little thing. Okay. All right. Everybody's chilling. That's cool. Me too. All right. Let's keep moving. Let's keep moving fast because time is flying. All right. So most of the time, I would say 95% of the time, it's better to read the charts first. Why is that? That's because, I mean, you can read the questions first and then try to answer a chart, or you can read the chart first. At some point, very quickly into most of the science, except for the ones that don't have charts, obviously, they're going to have you reading a chart. And if they're going to have you reading a chart, you might as well understand it. So it's not a big deal whether you want to try to answer the question first or answer the chart or look at the chart first. It's not a big deal. Personal preference for me is I like to look at the charts first. It doesn't take me very long, and I want to look at a few things and make sure I understand them in my head before I have to answer the questions. And it's kind of a fun game for me too, because I can, because I can kind of guess what the questions are going to be. And so in that way, I can kind of get a head start on things. It's a time test. You have to move quickly. So guessing that stuff gives you an advantage. Let's see. Okay. Clarissa or Zara, do you guys kind of know how to read a chart? Either of you or anybody else who would like to share? Madison or Lyra? Anybody? Do you guys have experience reading these charts? Do you like the science section? Do you hate the science section? That kind of thing? You have experience, Madison? Okay. Somewhat, Zara says okay. So Zara, I'm going to take that to mean like you have some experience, but like you're not like totally comfortable. Okay. I'll just go ahead. So the way I like to do it, and I think the best way to do it, is to read the X and Y variables first. So in this specific example, like they give you P and they give you altitude. So altitude, I right away understand, and I look at the numbers on there and I go, okay, so the altitude height above something goes from 0 to 70. I get it. P, I don't know what that means. If I don't know what P means, I'll go to the passage and read it. I'll go to the passage. I'll literally look for the letter P, and I'll see what they're talking about. Once I understand what it is, in this case, it's probably pressure, atmospheres. I'll just be like, all right, the pressure is going up from 0 to 1.5, and the altitude is going up from 0 to 70. And then here's the key to me is to tell a story. So I'll pick in this case, they have a bunch of different planets. Okay, I understand what that is. Planet Y. It's not my planet. It's some planet. And then I'll tell a story. And here's the story. As the pressure, or as the altitude, I actually like to tell it with the x-axis. As the altitude increases, so as it goes from 0 to 20 or 30 in this case, what does the pressure do? It goes down. It's a negative relationship. Same thing with the Earth, and same thing with Planet X. As the altitude increases, the pressure goes down. Now, I understand that the Planet X's pressure is higher compared to the Earth, or that Planet Y does not have as much pressure as the Earth. But I've told myself a story, and I've compared the variables to each other, like so I can compare Planet Y to Earth and Planet X. Any questions, you guys? Are you guys following along okay? Is this making sense? Anybody? Nobody? And by the way, you guys, you don't have to wait for me to ask any questions. You guys can you guys can always chat in the box and just like be like, you know what, you lost me, I don't get it, or whatever. Like, hey, like I had a question about something completely random, off topic, whatever. Just let me know. All right. So let's dig in. All right. So reading charts. This is a great example of reading a chart. So we just talked about we talked about one of these. I think it was figure 2, but let's look at figure 1. So I look at altitude. I get what that is. I know what altitude is. It's height off of the surface of the planet. But then when I look at the y-axis, I always look at the x and then the y. I see it says TK. I don't know what that is, so I got to figure it out. So then I would go up there, up to the passage, and I would skim, and I've made it easy here. I pointed to where it's you're referring to, but basically it says temperature. Okay, fine. I get it. So as the temperature changes, the altitude changes. Now I'm going to tell a story. Planet Y. Initially, as we start from an altitude of 0 and increase, as the altitude goes up at this planet, the temperature goes down. Then it goes to around 80. Then it goes up. Earth initially goes down. Then it gets to around, I don't know, a little bit more than the other one. Actually, initially it goes down, then it goes up, then it goes down, then it goes up. And then planet X, it's not even on the scale. I presume it's going down, and then it gets to 100 and it goes up. So you tell that, just very quickly in your head, you just tell yourself a story. Like, what's the pattern like, and what are the variables? Okay, as the altitude does this, the temperature does that. Super quick. Like, we're talking like 10 seconds, hopefully. And then the next key thing you do is you connect the charts to each other, the figures or the charts together. If you look at figure 2, it also has altitude. And the scale is a little bit different. Like, it goes from 0 to 70, whereas figure 1 went from 0 to 150. So the scale is a little bit different, but that's okay. It's altitude. As long as you note that the scale is different, that's fine. But then there's another variable on the y-axis I don't know. It's P. Well, I'll probably look around where they gave me the T definition. In this case, it says P is atmospheres. So hopefully you guys see where it says atmospheric pressure. So you don't have to necessarily know too much about pressure, but you want to tell the same story. So basically, as the altitude increases, what does pressure do? It goes down. Very similar to the altitude, although we must note that the altitude goes down and then goes up in a lot of cases, which is different than the pressure. The pressure just goes down throughout. And then the last figure, very quickly, again, it has altitude. So that's consistent across all three. Great, fantastic. They're all related to altitude. Again, note the scale. One of them, it goes to 150. One of the other one goes to 150. One of them does not. And then there's a third variable, and it's G. Again, we can find it very quickly. Gravitational field strength. Don't have to know what that means. Hopefully you know what gravity is and that you can equate gravity with gravitational field strength. And again, as the altitude increases, the G decreases. So they all share fairly similar stories. Zara, is that making sense so far? Give me a thumbs up or a heck yeah or whatever you want. Or you don't have to. Okay, cool. Any questions, Zara? Or is this something that you're looking to go over for this? Same thing for Madison. Same thing for what was it, Clarissa? Yeah. Okay. Everybody's good. I'm just gonna double check with you guys. Okay. Awesome. All right. So how do we answer a question? Okay, hopefully you guys can see this question at the bottom. So these ones I'm going over are relatively easy, but I just want to go over how we answer these. So this question number 15 says, according to figure 1, at approximately what altitude above their respective surfaces do planets X and Y have the same atmospheric temperature? And what is that temperature? Why don't you guys try to do this on your own? See if you can do this. And of course, if you have any questions, let me know. It's very important to take note of the fact that they mention a figure and that you identify the correct figure. If you're careless and you go to the wrong figure, you're going to find yourself in some pretty big trouble very quickly. So that's a good habit you always want to get into, is identifying the correct figure. So planet X and Y have the same temperature. Interesting. Okay, what do you guys think? Let's see. Hold on one second. All right, are you guys working on this one still? Everybody just type in the chat when you have the answer, okay? Or if you can't see something, please let me know. Planet X and Y. At approximately what altitude do they have the same temperature? So you can use the answer choices to kind of guide your way. Answer choice A says altitude of 50. If you look at an altitude of 50, only planet Y ever achieves that altitude. So I don't think it's possible for both X and Y to have a temperature reading if planet Y or planet X never gets that. Oh, wait, I said that wrong. Altitude of 50 for planet X. We need the same temperature. So, yeah, they both are at an altitude of 50, but they have different temperatures at that altitude. Or do they? Let's see what you guys think. Has anybody responded? See what's going on here. Anybody? Nobody? Zara? No thoughts? Let's see. What do you guys think? Any thoughts? I am just streaming. Oh. Okay. All right. Fair enough. Fair enough. All right. So I'll just talk you guys through it. Yeah. So according to their question, above their respective surfaces, what altitude above their surfaces do they have the same temperature? So let's look at altitude of 50. At an altitude of 50, and we're supposed to compare X and Y, right? At an altitude of 50, when do they have the same temperature? When do planet X and planet Y have the same temperature? If you look at their graphs, they don't really have the same one at 50. But if we look at 140, they actually cross each other right there. I don't know if you guys can see that red dot, but at an altitude of about 140, they actually have the same temperature. So they're basically asking, where do these two graphs intersect each other? So hopefully you guys can see that. Let's try another one. Number 16. According to figure 2, which of the following graphs represents the altitude above the surface of Earth's planet X and Y at which P equals 0.3? So they ask about 0.3. So because they ask about 0.3, in your mind, you can draw a line straight across at 0.3, okay? Altitude above the surface of Earth, of planet X, and of planet Y. So they want to know the altitude of all 3 planets at point 3. So planet Y, if you look here, is this dotted line. Its altitude. Can anybody tell me its altitude at a P of 0.3? Let's see. Can anybody? Or does anybody want to? Is another thing. Okay, Zara says, is it C? When did you say that, Zara? Oh, you're trying to answer this question? Were you answering the question, Zara? I would say it's 0, Zara. For the last question? Yeah, for the last question, the answer was, did I not give you the answer? Oh, yeah, it was 140 and, yeah, 225. Yeah, the last question was C, Zara. For the next question, what do you think about this one? If you're there. If not, no big deal. Okay, I'll just keep going. Sorry. Yeah, so they want to know which of these bar graphs represents the pressure, the altitude when the pressure is 0.3. So the altitude for planet Y appears to be 0, which seems to match this one and seems to match this one, but does not seem to match this one and this one. So you can cross those two out. So it's going to be F or G. Planet X. What value does planet X seem to have at a pressure of 0.3? Can anybody tell me? Not going to try to give you the answer, but I might just put a little arrow there. Not a good drawer, so my apologies for that. But can anybody, Zara in particular, since you've been such a good participant, do you have any idea what I might be pointing at here? Around 45, Zara says. What do you guys think? So, yeah, I agree, Zara. Look around 45. So, does answer choice F or answer choice G seem to show around 45 for planet X? F. Nailed it. Yep, you're right. All right, good. So, yeah, basically follow the variables. That's the name of the game here. All right. All right. All right. Now we have another question. Same chart, same question. Or not same question, obviously, but same idea. Atmospheric density and P are directly proportional to each other. Who cares? Not me. Not our. I mean, that we might have to think about that, but that's probably not a key detail. Based on figure 2, well, that's important. I've already pulled up figure 2, but obviously when you're doing the test, you're not going to have a teacher pull that up for you. So make sure you match the figures. Which planet more likely has the more dense atmosphere at an altitude of 5 kilometers? Altitude of 5 kilometers. Who is more dense? Earth or planet Y? Well, what values of pressure do Earth and planet Y have? Well, Earth seems to have a higher pressure. Could that mean more dense? Well, I'm no scientist, but more pressure, more dense, I've heard of something like that. So that seems to make sense. You don't always have to know the science completely behind this to get it right. So I would say Earth. I don't know what you would say, Zara. I don't want to, mess with you, but you're saying, Zara, do you have any opinion on this? Or Clarissa, if you're still there, Clarissa. Or Lyra, or Lyra. Zara? You want me to just go ahead and solve it? Earth, Zara says. Yeah, I think they have more pressure. Now, what's the reason? P for Earth is greater or P for Earth is less? What do you think, Zara? Great. Yep. Fairly easy, right? Not too bad. Yeah, totally 100% right. The more the pressure, the more the density. So Earth has a greater pressure. We found the number, and yeah, it's greater. Okay, so we're moving right along. These questions are not too bad. All right. Let's see what's going to happen now. At the surface of a planet, G is given by the equation. Oh no, we have an equation where G is a constant. Okay, well, that just means it doesn't change. Fine. M is the planet's mass. Interesting. Do they provide me with the planet's mass somewhere in this chart? I don't know. I don't see it so far. And R is the planet's radius. Okay, mass, radius, and G is a constant. So they've given me G, M, and R. Assume that Earth, planet X, and planet Y have equal radii. Okay, so that means the denominator is the same in all of them. Okay, fine. Based on figure 3, which planet has the greatest mass? Well, if R is always the same, and they're asking me about M, it's most likely that G is going to vary. Okay, well, what are the different G values of Earth, X, and Y? All right, look at the Y-axis. They have different values. Who has the biggest value? Zara, perhaps you have a theory. Who has the biggest G value? Any idea? Are you a little stumped? Question mark is a valid form of expression. Zara says X. What about Earth? Isn't Earth above planet X? So if Earth is above it, look at the y-axis. As the y-axis goes up, the numbers on the y-axis go up. And the numbers on the y-axis are labeled G. So as those numbers go up, G goes up. So M is the mass, G is a constant, and R is the planet's radius. Which has the greatest mass? Oh, interesting. So so I see what you're saying. So as Earth's G is higher, and they're asking about M. They're asking about M, and they tell us that G is a constant, so we can forget about G, pretend like it doesn't exist. And R is the planet's radius, and they all have the same radius. So G and R are gone. So that just means like G equals M. which planet has the greatest mass? And that M is the mass. And they've given us G. So the higher G is, the greater M is. So Earth seems to have the greatest G, so therefore Earth must have the greatest mass. Zara, does that make sense? So the answer would be Earth. Does that make sense? So they can't, yeah. So they canceled out the G by saying it's a constant. They canceled out the R by saying they're all the same, which R is the same as a constant. So then basically the G and the R just disappear. And if they just disappear, then you have a lowercase g equals M. And they're asking about M. So if they're asking about M, then all we can compare is the G. And the G is clearly the greatest for Earth. So therefore, the mass must be the greatest. Go ahead, Clarissa, if you have a question. And by the way, you guys, like I said this at the beginning of the class, like this is a pretty, quick class. I'm always on take lessons, happy to answer any questions you guys have. Yeah, of course. So I'm going to have an intermediate class after this one on the English section, which is kind of like the grammar. But then next week, I'm going to have an intermediate class on the reading as well as the math sections. So that would be Mondays, Tuesdays, and Thursdays at 6 p.m. and 7 p.m. Eastern time. And of course, you can always reach out to me through Take Lessons. I'm happy to answer any questions you have about like scheduling or anything like that. And we're going to be going over like a ton of detailed information relating to all these subjects. So we will be totally going very in depth into the reading section, as well as the English section. Hopefully that answers your question. Zara, as far as the science goes, I think we're good on that example. We've got a few minutes left. I think we've got enough time for one or two more. Yeah, let's finish out this one. Number 19 on the section says, based on figure 1, is the average kinetic energy of the gas particles in Earth's atmosphere more likely greater at an altitude of 40 kilometers or 80 kilometers? So, kinetic energy of gas particles and then the only thing they really give us that we can right away identify, hopefully you guys notice, altitude. That's your North Star. You know what that is. You might not know what the rest of the question is saying, but 40 kilometers, 80 kilometers. Sorry for my straight drawing here, but we can't all be perfect. What is the average kinetic energy? Well, what's the y-axis here? Temperature. Now, they're trying to see if you have a little bit of science knowledge, unfortunately, or fortunately, just depending on how you see it. Temperature is related to kinetic energy. Does anybody know how? Anybody? Zara? Temperature, kinetic energy. Okay, temperature, the higher the temperature, the more kinetic energy. So that's just a piece of science that you need to know to answer this. So the question becomes, they're asking about Earth. So for Earth at 40 kilometers, the temperature is about like 270. And for Earth at 80 kilometers, which is actually fascinating, it's about like 175. So Earth has a higher temperature at 40 kilometers. If it has a higher temperature, that means it probably has more, if you know your science, has more kinetic energy. So 40 kilometers, because the average kinetic energy of gas particles is directly proportional. That means directly proportional means it goes up. As temperature goes up, the kinetic energy goes up. So the answer would be A. I know we're running short on time, so I'm going to have to end this a little premature. But does anybody have any questions, or would anybody like to, share anything with the class? Or, of course, you can always reach out to me through Take Lessons if you have any questions. But I'm also going to attach right now a little practice test that everybody can use to help prep for their test day. Zara, when are you taking the test? Do you know? Have you picked out a date for your official ACT test? Same thing, Clarissa. Same thing, Lyra. Do you guys have any questions? April 2nd. Okay. So you're going to take it pretty soon. So my recommendation would be, Zara, to, identify exactly, I guess, identify your strong suits and weak suits, but most importantly, like, if you have a certain section that you feel like, for example, if you like science, but you're not scoring as well as you might like to, you can identify that section and really work on that section based on the fact that you're strong in that section, but are not performing up to your expectation. Another thing you can do, like that I highly recommend, is to take a practice test or just a practice section and then grade it, and then write one sentence for every question that you miss, explaining, why do I think I missed this, without like looking at the reasons why. And then go and look at the reasons why, like this. So they have a grading sheet where they explain the right and the wrong answers, and compare your explanations to theirs, and try to learn from theirs, and try to really adjust to your different interpretations. So Zara, I hope that was helpful. I'm going to be doing another class in about 10 minutes from now. It's going to be the English section. So the grammar and the context of the English section. So if you want to join, you're welcome to join. You just have to click that link to join. Anybody else? Lyra, Clarissa, anybody? If you have any more questions, let me know now. Please check out that practice test I provided. And also, of course, just, shoot me a message if you have any questions. All right, everybody. I'll see you hopefully in 10 minutes. If not, I'll see you tomorrow or another time. All right. Bye, everybody.